Hello everyone and welcome to my channel Chemistry by Miss Nidhi Banga. Today we will be talking about activity based questions from past years. Okay, so these are past year questions, specifically activity based questions. So let's get started. Let us start with something very simple. So this is our question 1. We have 3 test tubes containing 3 colorless liquids. One is concentrated sulfuric acid, the other one is concentrated sodium hydroxide, and third one is concentrated sodium sulfate. We don't know which one is which. We also have strips of pH paper. How would you identify the 3 liquids using pH paper? Okay, it's very simple that if you have sulfuric acid, that would turn the pH paper red. NaOH solution would turn the pH paper blue. And sodium sulfate, which is actually a salt made from H2SO4 and NaOH. Okay, so these are its parent acid and parent base. They are very strong acid and base. Therefore, upon combining, the salt that they produce is neutral. So Na2SO4, sodium sulfate, is neutral. It would turn the pH paper green since it's neutral, right? Which 2 solutions when mixed together in proper quantities can form neutral salt solution? These 2, H2SO4 and NaOH, when will combine in proper quantity, they will form a neutral salt solution, which is Na2SO4. Write the chemical equation for the reaction that will occur between the 2 liquids. Okay. So you have H2SO4 and NaOH, and it gives you sodium sulfate and water. Right? This is the neutralization reaction. Now we have to balance 2 sodiums here, 1 here, so let's put a 2 in front. Now let's balance hydrogens. On the reactant side we have 4 hydrogens. Here we have 2. So we'll put a 2 here. Okay, now everything is balanced. So this is your balanced chemical equation for the neutralization reaction. Okay, now till this it was very easy. But what happens is sometimes students get confused when they get confused between pH paper and litmus paper. Okay, so here is one thing. pH paper shows you different colors. Okay, it has many colors, light orange, red, and then green for neutral, and then blue, and then dark blue, and even shades of purple. But when we talk about litmus paper, you have only 2 options, red litmus and blue litmus paper. Litmus paper can only tell you whether something is acidic or basic. Okay, it will not give you different colors, right? So let's say we have the same question, but this time we have litmus paper, and let's say we have only red litmus paper. Then how would you identify the 3 colorless liquids? Okay, so let's see. So now you have 3 colorless liquid. One may have an acid, the other one has base, and the third one could be salt solution. We don't know which one is which. They are all colorless, right? And we have only red litmus paper. So what we will do is we'll take red litmus paper and we'll put in the 3 solutions. If it's an acid, it will not turn the red litmus paper into any other color, so it would remain red. If it's a neutral solution, in that case also the red litmus paper would remain red. But in case of base, the red litmus paper will turn blue. So let's say in the second case it turned blue. Okay, in the first and the third case it remained red. So we know this one, second one, is a base. But we still don't know whether first one is acid or the third one is acid, right? So what we'll do now? Now the blue litmus paper that we got after putting red litmus paper in basic solution, that blue litmus paper we will tear into two halves. Okay, and we'll put each half in these solutions. So if the blue litmus paper, if the half part of the litmus paper, blue litmus paper, if it turned red, then that is your acidic solution. And if it remains blue, then that would be your neutral solution, right? So this is how you can still identify if your solutions, the three solutions, are acid, base or neutral, even if you are given any one litmus paper, red or blue, right? So I hope this question made sense. Let's now move on to the next question. Okay, second question is about yellow sulfur powder being burnt in a china dish and the fumes are collected in a test tube. Okay, so sulfur is being burnt in the air, right? So when we are talking about burning is always a reaction with oxygen. Okay, so when sulfur is being burnt, that means sulfur is reacting with the oxygen present in air and getting converted into oxide of sulfur, sulfur dioxide, right? Now these fumes, it's a gas. So this is what came out and this is what was collected in a test tube, and then water was added to it. Okay, and then it was tested with red and blue litmus paper. So sulfur dioxide, when collected in the test tube and then water was added to it, what did we get? Water plus SO2, H2SO3. This is sulfurous acid. Sulfurous acid, as the name suggests, is an acid. So it will turn blue litmus paper red and red will remain red. So option B is your correct answer. Okay, even if you don't know what would happen with water, another clue that you can see here is that sulfur is a non-metal. The oxide that we got after burning it in the air was a non-metal oxide, and non-metal oxides are always acidic. Non-metal oxides are acidic and basic oxides are metallic oxides, right? So I hope this question also is completely understood. Let's move on to the next question. Now we have ethanol and ethanoic acid. How would we distinguish between the two? So ethanol is CH3, CH2OH. Ethanoic acid is CH3, CO double bond O and then OH, right? But we have two as the two colorless liquids. How would we distinguish between the two? Okay, there are many ways. One thing is by smell. Smell you can. Ethanoic acid is basically acetic acid, which will give vinegar-like smell. Okay, ethanol would give spirit-like smell, but that would be physical test. Let's say you are asked chemical test to distinguish between the two. Then the test is very simple. One of them is an acid, right? And we know that when acid reacts with metal carbonate or hydrogen carbonate, it gives off carbon dioxide, water and salt of that acid, right? So let's say you have ethanoic acid. It will combine with sodium hydrogen carbonate to give you sodium ethanoate, water and carbon dioxide. This carbon dioxide gas you will see as effervescence, okay, or as a fizz. And if you want to be sure, doubly sure, you make this gas pass through lime water, and if it turns it milky, then it's definitely carbon dioxide, right? So this is the chemical test to test between the two. All right, okay, let's move on to the next question. Give a test to distinguish between butter and cooking oil. Okay, so butter is our saturated compound and cooking oil is unsaturated. And when you have to test between saturated and unsaturated, there's a very simple test. We call it bromine water test. Now, bromine water is a brown colored solution. Brown colored solution. So what happens is, if you have an unsaturated compound, we know that unsaturated compounds undergo addition reactions and saturated compounds do not undergo addition reaction. So your cooking oil, which is an unsaturated compound, will combine with bromine water, where the bromine atoms will get added across the double bond in the cooking oil and will turn into a saturated compound. Okay, and in the process, saturated bromine would be added into that, and in the process bromine water will get consumed. Since bromine water, the brown colored solution, got consumed, its color got discharged. So if you have cooking oil in a test tube and you add bromine water to it, as soon as it enters the cooking, as soon as it gets mixed with the cooking oil, it will get consumed, and therefore the brown color of the bromine water will get discharged. And that is how you would know that the liquid in the test tube was an unsaturated compound. That is why it consumed bromine water, right? The same would not happen with butter, because butter is a saturated compound. Even if you add bromine water will not get consumed. Therefore, it will remain brown. It will remain there as such, and its color would also remain there, right? I hope it made sense. Let's move on to the next question. A student wants to study a decomposition reaction taking ferrous sulfate crystals. Write down 2 precautions while performing the experiment. Now, in decomposition of ferrous sulfate, let's say you have ferrous sulfate here, you would get ferric oxide, sulfur dioxide, and sulfur trioxide. These gases are harmful. So first thing that we have to, the main precaution that we have to take here is that the test tube, while heating on Bunsen burner, the test tube must not be facing towards anybody's face. It should be facing away from your face and away from other people's face, because you would not want to inhale these gases by mistake, right? So the test tube should be facing away from your face. Second thing is, while heating anything, you have to use a test tube holder, right? So these are the 2 precautions that you can take while performing this experiment. Moving on. When potassium iodide is added to a solution of sodium nitrate, a precipitate is formed. What's the color of the precipitate? Balanced chemical equation and the category of the reaction. Okay, so you have potassium iodide and then you have lead nitrate. Now the reaction that takes place between them is a double displacement reaction, right? The exchange of ion will take place. So potassium would combine with the nitrate and lead would combine with the iodide. And this is what you would get, right? It's not balanced yet, so let's balance it. 2 here and then 2 here, right? Now it's balanced. So the precipitate that you get is lead iodide precipitate. Okay, it's a yellow colored precipitate. That answers our first question, and second question is also answered now that we have balanced the equation. The two types of reaction in which this reaction can be placed, first is obviously double displacement, and second is, since a precipitate is formed, you can also call it precipitation reaction, right? So there you go. Let's move on to the next question. Design an activity to demonstrate decomposition reaction of lead nitrate. You have to draw a label diagram of the experimental setup, observations you also have to tell, and chemical equation and physical state of reactants and products. All right. So, since we are talking about decomposition reaction, we will have lead nitrate taken in a test tube. Label it as lead nitrate. Then we will heat it over the Bunsen burner. Okay, away from your face. The test tube should be facing away from your face. Right? Now, what are the products of decomposition of lead nitrate? You get lead oxide, nitrogen dioxide, and oxygen. Okay, let's balance it. Here you have 2 nitrates, so here you will have 2 nitrogen dioxide. Now let's balance the oxygen. We have 6 on the reactant side, 4 and 6 and 7 on the product side. So all we can do is put a 2 here. In that case, now we have 4 nitrates. So let's put a 4 here. Okay, now let's see. And we will obviously would have to put a 2 in front of lead oxide because we have 2 lead nitrates. Now let's see. It's balanced, right? Okay, so now this is the balanced reaction. The product that you get is lead oxide. Lead oxide is a yellow colored compound. That would be your first observation. Second observation is that you get nitrogen dioxide. It's a brown colored gas. Right? So that is your second observation. Now, physical state. The lead oxide is solid, nitrogen dioxide is gas, and oxygen is also a gas. And lead nitrate that we took in the beginning, that was also solid. Right? So we have stated the physical state of reactant and products. We have written a chemical balanced equation. Diagram and labeling done. Observations also you can write. Okay? Alright, moving on to the next question. A teacher provided acetic acid, water, lemon juice and aqueous solution of sodium hydrogen carbonate and sodium hydroxide to students to determine pH values using pH papers. One of the students reported the values as 3, 12, 4, 8 and 14 respectively. That means 3 is for acetic acid, 12 is for water, 4 is for lemon juice, 8 is for sodium hydrogen carbonate and 14 is for sodium hydroxide. Which of these values is incorrect? And state the correct value. The incorrect is obviously the second value because water cannot have pH 12. Okay, water has to have pH 7 because water is neutral. Right? Acetic acid is an acid, so pH 3 makes sense. Lemon juice is also citric acid, so pH 4 makes sense. Aqueous solution of sodium hydrogen carbonate. Sodium hydrogen carbonate is a base, weak base, but still a base. So pH value of 8, which is greater than 7, also makes sense. Sodium hydroxide, strong base, pH value of 14 makes absolute sense. What doesn't make sense is the pH of water, which is mentioned as 12. So it's obviously wrong. Okay. All right. Let's move on to the next question. You have pale green colored solution of ferrous sulfate in 4 separate test tubes, 1, 2, 3, 4. Okay, so let's take 4 separate test tubes and label them as 1, 2, 3 and 4. They all have pale green colored ferrous sulfate solution. Now we have added copper, zinc and aluminium in test tube 2, 3 and 4. So we have added copper here, zinc here and aluminium here. Okay, we did not add anything in test tube number 1. In which case or cases the color of ferrous sulfate solution will match the color of test tube 1. Test tube 1, where we did not add anything, would remain green, of course. Out of second, third and fourth, in which case the solution would still remain green. Okay, so let's determine the reactivity position of the metals involved. So you have aluminium, then zinc and then iron, and then after that you have copper. Okay, so obviously aluminium and zinc are more reactive than iron, whereas copper is less reactive than iron. So in case where you have added zinc and aluminium, they will be able to displace iron from their solution, right? But let's write the reaction with aluminium as well. Al2SO4 whole thrice, right? These two reactions will take place. Here the displacement will take place because zinc and aluminium, they are both more reactive than iron, so they will be able to displace iron from its salt solution. Don't forget to mention the state. The salt solution would obviously be aqueous and the metal would obviously be solid, right? Same here, the salt solution would be aqueous and the metal deposited would be solid, right? Now, in case of copper plus iron sulfate, nothing would happen because copper is less reactive than iron, so it won't be able to displace iron from its salt solution. So in second test tube, since no displacement is taking place, the color of ferrous sulfate would remain as such. Okay, so the first question is answered. Test tube second would have the same color as that in test tube 1. And the reason is that copper, being less reactive than iron, will not be able to displace, so the color of ferrous sulfate would remain as such. Second, the color of ferrous sulfate solution will fade and black mass would be deposited on the surface of metal. So in case of test tube 3 and 4, in both cases displacement has occurred and ferrous sulfate will obviously get faded, right? And iron would be deposited in both cases. So in cases 3 and 4, in both these cases, the color of ferrous sulfate solution would fade and black mass, which is basically iron, would be deposited on the surface of metal. All right. Okay, let's move on to the next question. On heating blue colored powder of copper nitrate in a boiling tube, black copper oxide, oxygen gas, and brown colored gas X is formed. Identify the type of reaction, gas X, chemical reaction, balanced chemical equation, and pH range of the aqueous solution of gas X. Okay. Now you have copper 2 nitrate and it's being heated in a test tube, boiling tube. Okay, so that means obviously this is decomposition since we have only one reactant. Now if you pay attention, this reaction would have the exact same products as that of the decomposition of lead nitrate. Okay, the only thing different would be that in lead nitrate you got lead oxide, and since this is copper nitrate you would get copper oxide, right? Remaining nitrogen dioxide and oxygen as the products, they would remain the same. Even chemical equation would remain same except for the obvious change, that is copper in place of lead. So this is your balanced chemical equation. The gas is nitrogen dioxide. The type of reaction is decomposition. X is nitrogen dioxide. Balanced chemical equation we have written. pH range of aqueous solution of gas X. Now nitrogen dioxide is a non-metal oxide. So aqueous solution of that would result into an acidic solution because non-metal oxides are acidic. So its pH would be less than 7. Alright, I hope this made sense. Let's move on to the next question. You want to test for the hardness of water, but hard water is not available. Which one of the following compounds you would dissolve in pure water to make it hard? Okay, so this can be simply answered by knowing what does hard water have. Hard water basically has the chlorides, sulfates and hydrogen carbonates of calcium and magnesium. Okay, chlorides, sulfates and carbonates or hydrogen carbonates of calcium and magnesium. So let's see if we have these things in the four options that we have. We have sulfate of magnesium. We have hydrogen carbonate of sodium, so that can't be it. Chloride of calcium, yes. Carbonate of sodium, so no, that can't be it. So we have second and third option as correct, so that would be our B. Okay, all right. Moving on to the next question. In electrolysis of water, if mass of the gas collected at anode is Ma and mass of the gas collected at cathode is Mc, what would be the value of Ma and Mc? So electrolysis of water, we have water breaking into hydrogen gas and oxygen gas. Let's balance the equation. Since we have 2 oxygen atoms here, we'll put a 2 in front and therefore a 2 here also. So this is our balanced equation. So this hydrogen would be produced at cathode because H plus is a cation. Cations go to cathode. Oxygen would be produced at anode because hydroxide or oxide is an anion. Anions go to anode, right? So Mc by Ma is what we have to determine. So the mass of gas collected at cathode is 2 molecules of hydrogen. At anode we have 1 molecule of oxygen. So mass of hydrogen is 1, 2 times that and then 2 multiplied to the whole thing makes it 4. Oxygen mass is 16 times 2 because there are 2 oxygen atoms will give it 32. So 1 by 8 would be your ratio and that is your option D. Okay. Moving on to the next question. On adding a few drops of universal indicator in 3 colorless liquids solutions X, Y and Z taken separately in 3 test tubes, a student observed changes in color as green in X, red in Y and blue in Z. Arrange X, Y, Z in increasing order of pH values. Okay. So X being green is neutral. Red in Y, so Y would be acidic. Blue in Z, so Z would be basic. So neutral would have pH 7, acidic would be less than 7, and basic would be more than 7. So pH value in increasing order. Lowest pH Y would have, then X because it's neutral, and then Z because it's basic. Okay, so this would be your increasing order of pH values. Which one of the three X, Y and Z will change the color of phenolphthalein and why? So your phenolphthalein is a colorless indicator. Okay, so it's a colorless indicator, and in acidic medium it stays colorless. It changes color in basic medium. In basic medium it turns pink. Okay, so phenolphthalein will change its color in basic solution, which is Z. Okay, so out of XYZ, Z will change the color of phenolphthalein. Okay, moving on. A few crystals of hydrated copper sulfate are heated in a dry test tube and list 2 observations. So you have a test tube and you have blue colored copper sulfate hydrated crystals. So this is the hydrated copper sulfate pentahydrate. Now when you heat it, what will happen? First of all, the water of crystallization will escape. So you will have water droplets condensing on the sides of test tube, right? That would be your observation number 1. Condensation of water droplets or condensation of water vapor into droplets on the sides of the test tube. Second thing is copper sulfate pentahydrate is a blue colored crystal. So when copper sulfate pentahydrate loses its water of crystallization, it becomes anhydrous copper sulfate, which is white in color, whereas the hydrated copper sulfate was blue in color. So the blue colored crystals that you took, they will turn white, and there would be water droplets on the sides of the test tubes. These are your 2 observations. Okay. Now, I hope this helped, and if you enjoyed the video, if you learned something from the videos, please like, share and subscribe. Thank you for watching.